I guess we're going to be I'm going to be splitting this with Matt. I'll be doing the first half and he'll be doing the second half on fire weather, and we've got 15 minutes to do both halves, so it's going to be not too detailed just because of time, but again, Mark's going to be sending the slides, so if there's anything that we can't cover, we can either talk about it at the end, or you could always email me if there's any questions. So we'll start now. Next slide, Mark. There are several ingredients that you need to get to make a thunderstorm, and all thunderstorms you need instability, moisture, and lift, and the lift provides the trigger. And to get a severe thunderstorm, you need wind shear. Next slide, please, Mark. Now, what is instability? Instability basically is if you give a air mass a push upwards, if it keeps going up, then it's considered unstable. If the air mass comes back down, then it's considered stable. An unstable air mass is characterized by warm, moist air near the surface and cold, dry air aloft. But of course, in our area, moisture is a big limiting factor here. Now, in the wintertime here, especially those people who live in a valley, we get the big high pressure over us, and we get the fog that gets trapped in the valleys a lot in December, January, early February. That's caused by very stable air, not unstable air, because the air is sinking. Next slide, please, Mark. What are some moisture sources in our area? Well, of course, we get Pacific moisture pretty much any time of the year, but especially in the winter. In the summertime, we'll get moisture from the southwest, the North American monsoon. And across the country, east of the Rockies, east of the Mississippi, we get Gulf and Caribbean moisture and moisture from the Gulf Stream. But those usually don't play as much of a factor in our weather. Next slide, please. Now, what provides the sources of lift? There are generally 4 processes that can cause the lift for thunderstorms, but again, since we're looking at time, I'm mainly going to focus on 2, orographic lift and frontal lift. Across our area, as everybody knows, we have quite a bit of terrain, quite a few mountains, and the mountains, the terrain can cause lift that can generate thunderstorms. Upslope flow on the windward side of the mountains is enough to generate thunderstorms, and the air mass is lifted as it goes up, and then as those clouds move across on the eastern side of the mountains, the leeward side of the mountains, they'll usually drop their rain or their thunderstorms as they come across, and then they will oftentimes fall apart. That's generally why the western side of the Cascades is wetter. Now we're talking big picture here, but that's generally why the western side of the Cascades, for example, is wetter than the eastern side of the Cascades. A lot of times you'll see a thunderstorm come out of the mountains, and it will, very close to the mountains, it'll create the rain and the thunder, and then as it moves further away, it loses its moisture and it'll just fall apart. And then also we have frontal lift created by convergence along either a cold front or a warm front, and that will create cumulus clouds, and if those cumulus clouds grow far enough, you can get a cumulonimbus cloud, which will create a thunderstorm. And you can get lift from the other 2 types here, thermal lift and jet stream lift, but again, since we've got a short period of time, not going to get too much into those today. And then we get wind shear, which is responsible for creation of severe thunderstorms. Wind shear is increasing winds with height, which will tilt the thunderstorm over. Storms can last longer because the rain-cooled stable air is not being pulled into the storm. And again, it's a key ingredient in significant severe storms. If you look at the illustration there on the left, you can just kind of see that because it's being tilted, you've got air, you got the warm, moist, stable air that's able to get pulled in behind the rain-cooled air ahead of the storm that keeps the thunderstorm moving. Whereas if it was like you have there on the far left, it will just not become severe because of the lack of wind shear. Next slide, please, Mark. There are generally 3 types of thunderstorms. We have a single cell thunderstorm, which is, as it sounds, it's just one thunderstorm. It's weak, generally brief. These are the most common types. They're locally. There can be a severe threat, but if there is, it's very localized. It goes up, it rains, you get your thunderstorm, you may get thunder, you could get some small hail, you could get some sub-severe winds. It'll last for a short period of time and then it dies out. Then you'll get your multi-cell cluster or line of thunderstorms. These are more organized. They can last for many hours. Wind and hail are more common, and there are more widespread and moderate severe weather threat. And then finally, you get your supercell. These are the most intense storms. They can last for many hours and create large hail damaging winds and tornadoes and a significant severe weather threat. These are not very common in this area, but they do occur. And a supercell thunderstorm will form if the conditions are right. It doesn't matter if it's Oklahoma or Oregon. So if the conditions are right, you will get a supercell thunderstorm. They're just not as common around here. Next slide, please. Now, generally, and I know Mark was talking about some of our changes to our messaging earlier, if we see a severe thunderstorm event, possibly 3 to 5 days out, we will start messaging that and outlooking it, saying, hey, we think this is possible 3 days out, 4 days out. As it gets closer, our messaging will start getting a little bit more frequent. We may start doing those webinars. And then when we get into the warning phase, we're basically saying, hey, it's here, or it's imminent, take action. Next slide, please, Mark. Now this was the May 30th, 2020 severe weather day. Basically, the Storm Prediction Center, which is located in Oklahoma, they are the national severe weather experts. They will issue outlooks several times a day on the threat for severe weather. Their colors go from light green to a purple. Light green basically says we think there's just going to be some thunderstorms around, but not severe. The darker greens is what they call marginal, isolated, severe. Yellow is slight risk. Orange is enhanced risk, and then moderate and high risk. Marginal risk will get, several times spring and summer. Slight risk a few times. Enhanced risk a couple times. Moderate risk very rarely, and high risk. Never say never, but probably not. But those are the code, and what they all mean, and they are based on their probabilities for tornado, wind, and hail, as well as fire weather and lightning potential. Next slide, please. And you can see March 30th we were in enhanced. If they think the conditions are right, they will issue either a severe thunderstorm or a tornado watch, more likely in our area, severe thunderstorm watch. And it covers a large area spanning several counties, issued by the individual office but coordinated through SPC. They'll last for several hours, and it means conditions are becoming increasingly favorable for severe weather. So if they think the severe weather is going to hit at 2 p.m., they'll probably try to get this out 10, 11 o'clock in the morning, for example. Next slide, please. And then a warning is issued by the local office based on radar and or storm reports, and they can usually last for 30 to 45 minutes to an hour. It means that severe weather is expected based on radar interpretation, or a report of severe weather has been received. Next slide. Now, our severe weather season usually goes from spring through early fall. There's no way to predict a seasonal trend in severe weather potential in the Pacific Northwest, at least one that's not terribly reliable. Usually we can get a sense of a favorable pattern 7 to 10 days out, with more specifics 1 to 3 days out. You know, we're kind of at the very early part of our severe weather season now, but it ramps up as we get into May and June and then through the summer. Next slide, please. When we're in what we call an upper level trough, when the jet stream dips to our south or over us, we're in an active severe weather pattern. Stormy periods occur when we have low pressure near the Pacific coast, increased moisture flows northward, and depending on instability in winds, this can promote strong to severe storms. Usually we can see this pattern developing maybe, again, 7 to 10 days out. Next slide, please. Well, we have a big area of high pressure over us and the jet stream well to our north. Generally, it's hot, what we call hot, dry, windy. That promotes fire weather concerns, but only isolated weak storms over the mountains. Now, of course, an isolated weak storm, not good for fire weather, but generally not going to be severe. If conditions are marginally good, sometimes you can get an isolated severe storm, but certainly not widespread severe weather. Next slide, please. And this year's outlook, we don't know. There's no skill in seasonal thunderstorm forecasting, and again, we should have an idea about a week out, and we usually will begin briefing on a strong severe event 2 to 3 days out, and then we'll conduct live webinars when widespread high-end severe weather is expected. And I think I've gone over my time, but that's my last slide, so I'll turn it over to Matt.
All right, thanks, Larry. I'm going to chat about the fire weather and also some of the products that we have here in the local office. We're going to start with the fire weather watch and the red flag warning. So a fire weather watch is going to alert land managers and public to upcoming weather conditions that could lead to extreme fire behavior. So this is looking 12 hours and further out. As we get closer to the event, it's not always, but most likely going to transition into that red flag warning, and that is going to occur within 12 hours or immediately happening. And really going to be extremely careful around open flames or around any fires that are actually out there. Now, again, I mentioned that just because it's a watch doesn't necessarily mean that it could be a warning. We could drop the watch, and if that occurs, a lot of times we put a fire weather section in the AFD as well and kind of explain our reasoning behind that. So if you were wondering where the watch went, you can likely find some reasons why we dropped the watch in the AFD. So keep that in mind as well. Now, the red flag warning is going to be zone specific as well. And what leads to those are a couple of the scenarios that I'll go into here right now. So the three scenarios, now this is going to be assuming that the fuels are cured and ready to go, are going to be the abundant lightning, dry and unstable conditions, and dry and windy conditions. So the abundant lightning, what we're really concerned about is numerous fire starts. Usually the warnings aren't issued when it's accompanied with a significant amount of rain, usually about 1/4 of an inch. But again, it's very specific to the event, because if it's followed by a very hot and dry pattern or weather, we still will likely issue the warning. So it really is event specific. Now, for dry and stable, we're really looking at the explosive growth. Larry kind of went into the unstable atmosphere situation, and that's really what we're concerned when we're looking at dry and unstable air mass moving through, and extreme burning conditions are likely. This is mainly going to be significant for fires that are currently ongoing. We're looking at kind of Haynes 5 and 6. Definitely with a Haynes 6. Sometimes we'll issue it with a Haynes 5 in terms of the red flag warning. It's going to really be based on if there are large fires in the area and if they will be impacted. When we're looking at kind of the dry and windy conditions, we're really looking for phenomenon or event based, and a lot of times those aren't issued for the entire zones. We can kind of, the fire weather zones, we can pick kind of an area in order to kind of issue that. So the criteria is very zone specific. Usually the kind of the wettest situation in some of our zones is closer to about 15% humidity, 10-mile-an-hour wind speeds, kind of that direction, and getting drier and windier from there. So as we're looking into the products, we're going to go kind of large scale and go into small. So the first one's going to be the outlook. That's going to give us a really good idea of kind of a broad stroke of the nation, what's going on. It's going to be issued by the Storm Prediction Center in Norman. It's going to highlight the threat areas, and it's going to categorize them in elevated, critical, or extreme criteria. It's also going to include some information that's going to be related to some of the dry thunderstorm and if it's a possibility in that area. And again, it's also a really good kind of broad scope of what's going on. They're going to break out into day 1, day 2, and day 3 to 8 day parts. And definitely check this weather this website out, because under these outlooks, they're actually going to have some composite maps that are going to be more region specific. It uses some model data and breaks it down in 3-hour increments through the day. So definitely keep that in mind. It's a really good tool. Now, as we kind of go a little bit more in kind of the regional aspect, we're going to have that fire weather forecast page. This is going to be a quick kind of Western region, local region situation where we're going to be able to quickly access the fire perimeters. We're also going to look at weather observations and radar. You can see with the image those check boxes there, and you can layer it, which is really neat. So you can highlight 2 or all 3 and kind of turn them off and on and see where they're at. The menus that are also there with some of our products include the fire weather forecast, which I'll get to here in a second, active red flag warnings and watches, and the current obs and radar you can see there. It also includes a link to the spot forecast monitoring page. Get to that here shortly too, and that's where you can submit that that spot request. So this is the FWF. This is going to be the fire weather forecast. We're going to issue these twice a day, in the morning at by 7 a.m. and by 3 p.m. So as you're looking at this, the left is going to be how it starts out from the very beginning. We're going to have a discussion for the entire area. And then on the right, that's going to be more specific fire weather zone forecast. So the 7 a.m. is going to look at today and tomorrow. The 3 p.m., it's going to look at tonight, tomorrow, and the next day. So it's always going to look 2 days out. So definitely keep that in mind. So that's a really great tool. And also another product that we have is going to be the spot forecast, the monitor and request page. So the monitor page is really great to quickly look at any spot requests in the region and where they are. Now, they can be issued for a number of incidents, wildfires, prescribed burns, but also hazmat, search and rescue operations, and other miscellaneous events. And we can tailor these to those events. So wildfires, prescribed burns, we're looking at 20-foot winds. When we're looking at search and rescue ops, and we're also doing some vaccination clinics, we're looking at more closer on the ground. So there's the URL there. That's the request page, or that's the spot monitor page. But if you wanted to or needed a spot request for a specific area, you can hit that request page on the top left, and then that takes you to our spot request page. Now, we'll need some information with this, so keep that in mind. We'll definitely need the location. It can be either lat long or a address. So either one, and then we'll go to the incident type. So either fire, hazmat, search and rescue, or other, like earthquakes or a special event, a fair, vaccine. And then after that, you go into the specific request form, really what you're looking for. You're looking for fire weather information, the specific parameters that you desire as well. You'll click them, and how long your forecast that you're wanting for. So we'll look at a couple other quick products. So we're going to have the email briefings, like Mark mentioned. We're not going to harp on this too much because he went through a really great job. Obviously, if it's going to be a little, very strong event or extreme high, we're going to have multiple email briefings days out. If it's going to be more of a marginal event, it may just be the day before. So definitely keep that in mind. And if it is going to be one of those higher or extreme events, likely even medium event or moderate event, we will, depending on the threat, we will have the live webinars as well, like Mark mentioned. Now, the nice thing with these webinars is we can, like we are doing now, we can chat back and forth. And if you have immediate questions, we'll be able to take them right there on the live webinar. So it's going to, again, be more reserved for those higher end events. And if it's a really high event, like a higher extreme case, we'll hold multiple ones. We're not just going to hold one for one event. We're going to go into more detail and more technical aspects of that forecast. We did want to just kind of highlight this as well, the IMET program, and I'm not an IMET or a trainee yet, but I am going to be on the path there. But they're specifically trained fire weather meteorologists that also can do other things too, mostly fire, but can do fairs and events and that type of thing. And they're boots on the ground. So they're there. Normally with a fire, they're there for 2 weeks and then they get replaced. But yeah, we're on the ground. We're doing specific forecasts for that site. And last year was a record year for the IMET deployments across the Western US. And likely that will continue, as we go forward. So that's all I had. I think it was a little long, but yeah, again, all this stuff will be sent. So if you guys also have any questions, again, the office is always open. Feel free to give us a call anytime.
Great job, Matt. Thanks for highlighting that, and Larry as well for the severe weather piece. I know we're running a little bit behind schedule here. Ed, I'm going to ask you, do you think you can get through your slides here in the next 7 minutes, or would you like me to try and go ahead and rearrange the agenda and pass it on to John first? You have to unmute yourself, I believe, Ed.
Let's rearrange, and
Okay.
so again, John, make sure he gets his time. I want to make sure John and Peter have plenty of time to do theirs, do their show.
Sure thing. Hey, John, are you ready to go with your segment of the presentation?
I am ready to go.
Okay,
I'm
let me
assuming you can hear me and see me okay?
I can hear you great. I'm going to make you the presenter.
Okay. And let's see, I want to share. Let's see here. Screen. PowerPoint. There we go. All right, should be my PowerPoint screen.
Yeah, I can see it. Looks good.
All right, very well. So I'll proceed. Okay, so I'm John Saltenberger. I represent the U.S. Fish and Wildlife Service in Portland, Oregon. I'm a staff member, meteorologist at the Northwest Interagency Coordination Center here in Portland. I work in fish and wildlife in the refuges division, and the refuges occasionally catch on fire, so there is a fire management part of the U.S. Fish and Wildlife Service, of which I'm part of. I am one of the meteorologists attached to Northwest Interagency Coordination Center. Okay, I work in the Predictive Services Program as part of Northwest Interagency Coordination Center, a chain of 10 such centers across the United States. Interagency coordination centers are tasked with interagency fire support. The Predictive Services Program is a relatively new player in the interagency fire world. We've been in business since about 2000. The mission of the Predictive Services Program is to analyze and predict fire danger, fire weather, and fire resource capabilities to determine what's called wildland fire potential. That's a term that's straight out of the National Fire Working Group glossary. Wildland fire potential. How do we interpret that? Officially, from the glossary, wildland fire potential is defined as this: significant fire potential. And that is the likelihood that a wildland fire event will become big enough, large enough, costly enough, complex enough to require mobilization of extra firefighting resources from outside the area in which the fire situation originates. In other words, it means that local firefighters have been overwhelmed by the the hazard and the complexity of a fire event, so they're bringing in outside resources to help manage that blaze. Okay, in working definition, what is what we call significant fire potential is defined as this: it's costly enough, dangerous enough to require a type 1 or a type 2 incident management team deployment. And that's costly, and it's time consuming, and it involves a lot of movement, a lot of money spent, a lot of resources shifted around both within this geographic area and other geographic areas in order to mitigate response to that wildland fire incident. Incidentally, I'll point out that most of our business is wildland fire incidents, although we do occasionally have a hand in mustering resources for hazardous material spills, search and rescues, other kinds of natural disaster responses, but it's about 90% wildfire. Okay, so what this center does then is try to anticipate the conditions under which large, costly fires will occur in the Pacific Northwest, Oregon, and Washington, our region. And when such events occur, then this center here, is responsible for moving resources to the area where the fire is burning. When fires break out on individual national forests or BLM districts or national parks, local firefighters are the first to attempt containment of that fire. If that fails, they'll call for help from their neighboring forests and parks and districts to try to put that fire out. And if that fails, then they turn to us, the Northwest Interagency Coordination Center. So we're really the second or third line of response when it comes to fire mitigation. As such, we tend to only get involved when fires become big, large, costly, and nasty. We're managing fires, large fires within the Pacific Northwest, but we're also looking at what our neighboring regions are doing throughout the United States. And we trade firefighting resources back and forth on a daily basis, depending upon who has the highest fire potential at any given day or any given time of year. Right now, we're sending a lot of resources down into the Southwest and into the Great Basin because that's the driest area that's first up with large wildfire activity. Okay, so what we're doing here at NWC is we're constantly reporting on the status of fire activity in the Northwest, mobilizing new resources, providing a logistical support for those resources, planning for possible future resource usage. And we're pre-positioning or prioritizing firefighting resources around the region in response to that. As such, the 3 to 5 day planning window is crucial. We're constantly looking at 3 to 5 days because it takes that long a time to get a lot of firefighting resources from outside the area marshaled and organized and sent to where they need to go. So we're constantly looking at 3 to 5 days, sometimes more than that. So here in the Pacific Northwest, we've broken Oregon and Washington up into 13 different climatic rating areas under which we do fire danger, fire potential, and fire weather daily ratings. Those 13 areas were determined by daily fluctuations in relative humidity during fire season. When I say 13, I mean 12 different rating areas plus the GAC as a whole as being the 13. Okay, so within each one of those 12 rating areas or the GAC as a whole, there are 72 key fire danger and fire weather reporting sites that are giving us on a daily basis what the weather has been, winds, temperatures, humidity, solar radiation, vapor pressure deficit, and those are converted into fire danger values on a daily basis for each one of those reporting sites. We average them across our 12 different rating areas and the GAC as a whole, the 13th rating area. And we're looking at the fluctuation in daily fire danger and fire weather in concert with each other to start to game out the potential for getting new large costly fires on the landscape. Okay, so in each one of those rating areas, we're constantly looking at fluctuations of the various measures of fire danger. We're looking at ignition, mainly from lightning, but also from humans as well. We're looking at daily fluctuations in temperatures, relative and humidities, and winds across the landscape. And we add that into a large and ever-expanding database of information that we sift through looking for patterns for a large wildland fire relationship. So we're constantly looking at fluctuations in fire danger. And we find that fire danger waxes and wanes from day to day as weather patterns change across the geographic area or any one of our individual rating areas. And there's upwards and downwards fluctuations in fire danger. In this case, we're measuring fire danger with energy release component, one of the parts of the National Fire Danger Rating System. We find that those relative maximums in fire danger that occur several times each summer are important because it tends to be that large, costly fires break out most likely around the max or slightly after the maximum of a fire danger relative max during fire season. So any given year, we may have several of those relative maxes that occur. It's the times of those maxes that the conditions are right for new large wildland fires on the landscape or growth of existing fires. Okay, so we feed all that information into our what we call our 7-day significant fire potential model. The model that's trying to game out what's the potential for getting large, costly wildfires on the landscape by looking at past history. So we measure fire danger, either energy release component or 100-hour dead fuel moisture from the National Fire Danger Rating System. We measure the fire weather, the winds across the landscape, the vapor pressure deficit, the atmospheric lapse rates. And then we're also measuring the number of ignitions, both from humans and from lightning on any given day and entering into that database. We sift through that database and we find that doing a logistic regression, we can find that there are weighted contributions from each element that are used to predict future potential for large wildland fires. So, for example, Central Oregon, our PSA predictive service area called NW06, to be specific about it, to game out the potential for a new large fire on the landscape in PSA NW06, Central Oregon, we first need to know what the 100-hour dead fuel moisture value is, multiply it by a coefficient, know what the average wind across the landscape is on any given day and multiply it by a coefficient, know what the vapor pressure deficit is across the landscape, multiply it by a coefficient. So there's our fire danger element. Here are 2 weather elements. And then we also have an ignition factor, which is modeled in both ignitions from humans and ignitions from lightning. That gets factored in as well, plus a constant. All that information gets fed into a logistic regression equation. And when we shake it all out and turn the hamburger grinder, what comes out of it is what is the potential or the probability of getting a new large fire on the landscape, given all these varying contributing factors. Just a few facts. The most important fact component in the Pacific Northwest is fire danger, but also fire danger in relationship to lightning. When we get lots of lightning, we get lots of starts. The drier it is, we get more and more starts. Roughly half of the fires that occur in Oregon and Washington occur from lightning. And our initial attack firefighters, the first on the scene, have an excellent record of keeping human-caused fires small, even on dry, windy, unstable days. They corral something like 95 to 97% of fires, even on dry, windy days. But when we get lightning storms, we get so many starts in a short period of time that we tend to have more large fires because of lightning events rather than wind or dry and unstable events. Some of our rating areas, up to 75% of the fires that become large ones are caused by lightning. And that's typically because, or for 2 reasons. One, because lightning comes and brings us lots of ignitions at once. And lightning can hit up in the backcountry where it's difficult for firefighters to access to. So those contributing factors mean that lightning tends to be a bigger contributor to large, costly fires in some of our PSAs. So our significant fire potential product that we publish each day, the 7-day significant fire potential product, is simply a probabilistic large fire forecast. I should point out it has weather symbology on it. It is not a weather forecast. It is a large fire potential forecast, a probabilistic one. So our role here in predictive services, when we were established with the implementation of the National Fire Plan back around 2000, we were never intended to compete with or replace the National Weather Service, nor were we intended to supplant local fire management practices and knowledge and local fire management plans. The intention of the predictive services program is to improve regional fire management logistics and intended to improve decision-making and synthesis of a variety of bits of information, fire danger, fire weather, fire behavior, fire intelligence, to improve regional and national decision-making. So our 7-day significant fire potential product, one of several that we issue, First and foremost, it's not a weather forecast. It's a fire potential forecast. Specifically, what is the potential for initiating new large fires on the landscape? Therefore, the days that we call high risk for new large fires on the landscape aren't necessarily the same as what the Weather Service issues for red flag warnings. There is some crossover between the two, but they're not necessarily the same thing. Our 7-day significant fire potential product, our flagship product, when our risk factors rise above a 20% large fire probability, we call that a high risk day. And when significant fire potential rises above 20% risk threshold, we designate it in red as a high risk day. Sometimes those correspond with red flag warnings, sometimes they don't. And that's not necessarily a conflict. So why is a high risk day not necessarily the same as a red flag warning? High risk days take into account the combination of fire danger, fire weather, as well as the historical ignition risk as well. Some differences between what Predictive Services does and what Weather Service does. We don't do red flag warnings. That's the Weather Service's job. We do not do wildfire spot forecasts. That's the Weather Service. Nor do we do smoke management regulations. That's the purview of the state of Oregon and the state of Washington. Okay, so on a daily basis, we're tracking that fire danger, we're tracking the ignition potential, we're tracking the fire weather elements and weighting them appropriately as designed by statistical studies, logistic regression for each of our PSAs, and inputting that information. Then we forward project that out to 10 days into the future to try to estimate what is the potential for new large fires on the landscape. That's what I have, unless there's any questions from the group.
Well, thanks, John. I really appreciate you jumping on here and giving us, you know, an overview there of kind of what you do and your role in the whole wildfire forecasting, I guess, spectrum. I think for me, anyway, it's given me a lot more insight into how complex, you know, all the information is you have to take in and kind of synthesize to result in a forecast. I have one just brief question for you before we go on. You know, what has been kind of, from your perspective, one of the more notable challenges in working with the National Weather Service? You know, my mind goes immediately to the fact that you're responsible for such a large area, and Weather Service offices generally have kind of this, you know, sub-region that's composed of kind of almost a random assembly of counties, you know. So I wonder if that enters into the equation at all.
Yeah, to some extent it does, because we have these broad PSAs, each of which can encompass several fire weather zones or more. And so that we're kind of looking on a broad scale, say maybe a more broad scale than the National Weather Service does, focusing down. And because we're looking at a broad and geologically, climatologically complex area, we will sometimes miss over the details that the Weather Service will be looking at in their local areas and paying attention to. And that is not to say that they're not important. It's just to say that we have such a kind of a broad view that we don't have the time to devote to individual weather elements, fire weather elements in a particular fire weather zone that the Weather Service does. The other difference, of course, is that these broad polygons that I call are 12 different predictive service rating areas. Once we do the averaging of weather, like say vapor pressure deficit, wind, and temperature and humidity across a PSA, it becomes an opaque polygon. We don't do any further delineation, say, of fuel types or elevations within a PSA. It's just what is the fire potential in that particular PSA, as opposed to the Weather Service, who may be looking at several fire weather zones within that PSA, some of whom may be in red flag warning criteria, and some of whom may not be. Again, I hasten to point out that that is not necessarily a conflict. You know, if we have out advisories and you don't, or vice versa, don't necessarily say that somebody's wrong or somebody's right in such cases. It just means that we're looking at different criteria and trying to answer different questions. Our product is not in any way related to firefighter safety. It's not related to, you know, fire intensity or rates of spread or any fire specifics, simply because we're trying to answer a statistical question. What's the chance that a new large fire will break out on the landscape in this PSA on a given day? Whereas what the Weather Service is trying to do is more fine-tuned, and the red flag warning product is much more tied to, say, firefighter safety than ours is, which is more tied into uses of fire logistics around the geographic area. Conditions which may cause fast-moving fires that challenge firefighters and could potentially be dangerous, the Weather Service will issue red flag warnings for. But that same fire that a Weather Service would issue a red flag warning for may not necessarily constitute extra movement of firefighting resources around the geographic area. So it's not that we're ignoring that fire, it's just that we see from historical standpoint that such fires, even if fast moving, don't necessarily require a lot of extra firefighting resources to manage. I realize I'm saying a lot. I hope that helps answer your question.
I think it helps refine the different perspectives and roles, where we're kind of on that more immediate end. And as you mentioned, safety, and not just firefighter, but public safety as well, both of those facets. Out of curiosity, I went to your webpage and I was looking at the significant wildland fire potential outlooks, and looks like kind of right on cue. Moving into that above normal risk there into June, and I think even July it becomes more prominent. So,
yeah, I'm a little hesitant to start painting those areas in it being as unusual risk in June, because typically fire season really doesn't start to open up until July. But that area has been so dry so far this spring, and with little relief in sight, that I start portraying it as at elevated risk in June this year, and then going into July, and then we'll expand that which from there as conditions warrant.
Yeah, and I know the Southwest has been especially dry too, and so that's a big area of concern as well. Again, seems to be pretty consistent year after year for the last few. Okay.
They're calling for a pretty good monsoon, so I think they're erasing that area as being at risk in July. It's good news, but up until July, it looks like the door is open.
Absolutely. Well, in the interest of time, I think we're going to move on to our next speaker, and that's Peter Brewer with the Oregon Department of Environmental Quality. And Peter, you're able to unmute yourself, it looks like. So I'll pull up your presentation and let you take it from there. You tell me when to move the needle.
All right, move to the next slide. Okay, I'll try to be a little brief on this topic, but just to get a little different perspective going in. It's really interesting to hear of the predictions and all that, but then you go into the actual, this is what happened. So we have our fires that burned in Oregon, Washington, Northern California last year. Gee, almost 5 million acres. We were 1 point something. I'm not sure. Maybe somebody can raise their hand. 1.2, I think, about in Oregon. A lot of that happened in a very short time. But that was pretty record high for us. But you see that kind of climbing in frequency that just keeps going up. Next slide. Okay, we'll jump quickly. We'll go into more of a specific event into September of last year for wildfire. But overall, this is maybe a little hard to understand. On the left side is 0 to 40 incidences, and it's really highlighted by Medford, Klamath Falls, because they had such high number of fire incidences over the years that drives up the scale, but it's still pretty significant if you're looking at, oh man, we had about 10 days over unhealthy for sensitive groups in Portland last year. But you look around, this gives you the whole state kind of approach as to what happened last year in general, but you can see over the years the fire behavior. A little bit more problematic down in the Southwest and the South Central area, but also, it's not unprobabilistic in other locations either in the last number of years. I'll just quickly go over for those who aren't as familiar, but just in terms of air quality, good air quality is about 0 to 50% of the standard air quality standard, moderate 51 to 100% of that standard. Unhealthy is up to 150, or unhealthy for sensitive groups, I should say, USG. So here we have air quality days greater or equal to unhealthy for sensitive groups caused by wildfire. That's up to 150 on the air quality index scale, or up to about 55 micrograms. Unhealthy then is 151 to 200 on that range that we use for everybody, or it's 55 to 150 micrograms. Very unhealthy is up to 300 microgram, or on the air quality index range, or up to 250 micrograms. But anything over that into hazardous is over 300 on the air quality index range, or greater than 250 micrograms per cubic meter. So they start kind of evening out a little bit. But we'll get into that here in a little bit. All right, next slide. Okay, I do want to talk a little bit about Medford. We're going to hit these kind of similar slides for the next number of them for the different areas in Oregon, covering that wildfire period, which is mainly in September, about September 7th. I think things really started off, and for about 10 days after that. So most of the state and many people here in the state remember just kind of like a darkness and no sun, no nothing for days and days and days and days. It depended where you were, if it was only 5 days or 7 days instead of 9 or 10. But in that time frame, we did hit up to, say, Ashland on the 13th was 432 micrograms per cubic meters. That was huge. And Eugene, 400 to 430. Cottage Grove, 430. Oak Ridge, 490. Eugene, over 500. And so on. And you just go across the state, and much of the state was just hit with horrible air quality. And that you can see on this picture in that kind of maroon color. That's hazardous level air quality conditions. Purple is very unhealthy. Red is unhealthy, and orange is unhealthy for sensitive groups. Is still over the standard. So all of this is bad. It's all bad for air quality. But then you look at Medford though, and you go, my gosh, you know, we had a bad year way back when. Another bad year in 2002. Couple, and then wow, we've got a lot of poor air quality, especially in the last 4 years to 8 years or so. Yeah, that's a big problem. And 2018, of course, is very problematic for Southern Oregon. And it doesn't mean all the fires are right in that area. Sometimes smoke blows in from Northern California, or it comes in from far away, as we're starting to see. Next slide. Just a little bit on Portland. They've had pretty good air quality all the way up until 2015, and then 2017, 18, a little bit of problem. And then you look at the change in colors to 2020, you know, having lots of hazardous days, and then purple very unhealthy, and so forth. So Portland and the 1.5 million or 2 million people in that huge area are being woken up with fire, and it's not good from a DEQ standpoint, but it's the whole state's getting impacted. Next slide. Klamath Falls, also down in that southern Oregon, or South Central, as I call it. In 2018, the 38 days of poor weather, but only 3 in the very unhealthy. They were actually a little bit in a not quite hit as hard in Lakeview, maybe a little bit over in Burns and in Ontario this year. It's not quite as bad of air in terms of harshness, but still there's plenty of days overall where they're impacted. But you see those trends and that level of smoke impact. And in 2002, from the fire over in the Kalmiopsis area, I keep forgetting the name, if it was that the Biscuit Fire, that blew a lot of smoke over into Klamath Falls. I actually lived in Klamath Falls 2006 to early 17. Kept my house in Bend, but I was living down there working, and so I experienced some of this smoke as well. Next slide. So then we see that as you get into more of the central area or your south central or southwestern and on western side of Oregon, you have more days in the hazardous range. So for 2020, there's a lot of problem days in Central Oregon, but they've had a number of their poor air quality days over the years as well. But yeah, you think of all this in one shot is pretty tough. 6 days in hazardous, 2 days very unhealthy, 4 in USG or unhealthy for sensitive groups is a rough year. And next slide. We switch to Eugene, and I just made the note there that having 8 days of hazardous air quality, yeah, that they had the most by a day, but they had pretty much 11 straight days of poor air quality. To just you're in a kind of for most of us, we remember being in a little bit of a dream world. It was a nightmare in some very real ways, and other ways you just had to stop time. And at least for me, in deal with smoke about 18 hours a day. But yeah, Eugene, pretty much good air quality until the last few years. And so that's showing us a problem overall that I do want to highlight here. Next slide. Salem, great air quality until very recently. So Salem is usually in that great range, kind of like Portland. They don't get the poor air quality, but we sure have more recently. And last year was very, very hard for them. Next slide. And we jump over to La Grande and way over a little closer to home for a lot of folks. But then even though their air shed was pretty good, you see for 2020, you see 9 days of hard hit. And maybe they're only very unhealthy. They weren't in that hazardous range that we could tell on the daily average. It did hit hazardous at times, but it's pretty good overall. But overall, for the long year, multi-year trends, it doesn't look good for impacts, whether it's a local fire or a lot of these are from fires far away. It's a problem for La Grande. Next slide. And I, of course, have to show Sisters because I live by Sisters, but yeah, we had pretty bad air quality this year. Is all in that fire time frame in September. But yet this shows difference from Bend. Maybe in 2017, they were a handful of days lower, like 14 days or 15 or something like that. Yeah, 15 in 2017. And Sisters had 27 days of poor air quality because of local fires. So this just kind of gives you an idea. If you're by an area that can have local fires, you can be grossly impacted, very different from everybody else. But also then last year we got hit. There was a local fire, is kind of in and out, but overall we got hit by the broad firestorm, like most people, where we didn't have fire on the east of the Cascades, but we had the smoke for days and days and days. So yeah, that's about all I wanted to highlight. The severity of the smoke, the hazardous level of the smoke, and that increasing level that we're seeing of more very unhealthy and hazardous at times, partly due to the drier weather we're seeing, and the fire, just the potential for fire, but we see just a natural drying too of our forest areas. That's kind of it in a nutshell. I just wanted to let people think about that, and maybe there's some questions.
Yeah, thanks, Peter. I really appreciate that. I'm hoping we can get to, I had to rearrange the schedule a little bit, and I wanted Ed to get a chance to talk a little bit about some of the probabilistic messaging and uncertainty. So if we can just jump into his presentation briefly, and then, we'll try and have a few minutes at the end of that to have some open discussion. Certainly understand if people have to go, we're getting close to the top of the hour here, but wanted to give him a chance to present. So Ed, I'll go ahead and pull it up, and it's ready to go when you are.
All right, Mark, can you hear me? Let's go right on to the next slide.
I can.
We're going to talk about using, probabilities and uncertainty in the forecast process. So, this is our current direction, and this transformation is underway, and actually has been in the works for a long time, as far back as 2011, believe it or not, when it came to the Weather Service and our strategic plan for Weather Ready Nation. The biggest takeaway for this plan is a shift from simply a product-focused service to one that goes beyond that with actual interpretation and consultation services. Again, this shift has been occurring, and we can do this because of advancements in our field, from satellite data, where we now get data every 60 seconds at a 0.5 kilometer to 2 kilometer resolution, to high resolution model guidance. I guess the big bottom line is this comes in the form of providing forecast confidence and direct probabilistic information in our forecasts, and I'll explain what that is next. So let's look at a traditional forecast first, an example of a higher level forecast information. So a traditional NWS forecast, that is, something in the vein of 60% chance of thunderstorms this afternoon, or, thunderstorms will be in the event area this afternoon. So this kind of progression is going beyond that and saying, instead of 60% chance of thunderstorms this afternoon, it's thunderstorms between 2 and 5 p.m. These storms will have frequent cloud to ground lightning with a LA-LA4 and an 80% chance of occurrence. So that's the type of progression we're trying to see here with this direction. So we talk a lot about confidence, and I just wanted to talk about it a little bit, because confidence is at the center of our DSS, not uncertainty when it comes to our briefings. Uncertainty, that's a scientific term, and it really isn't compatible when it comes to clear plain language. We use it to define model spread or when solutions diverge. But outside of our community, we refer to how confident we are in the forecast or potential outcome. Ultimately, the general public especially can be confused by it, as it can be misinterpreted as we don't know, which is certainly not the case. So we translate uncertainty to confidence, and we use forecast uncertainty with forecast confidence pretty synonymously. So this is just an example for like high spread to high uncertainty to low confidence. So, and you can see in our new DSS briefings where the location of confidence information will be. Right after the what, it'll say confidence, low, medium, moderate, or high. Next slide. So alongside forecast confidence, we're going to be communicating probability information. So what that is we want to provide information that actually communicates either a direct likelihood or a threshold likelihood, or a predictive interval or range to provide a better depiction of the range of possibilities and where the observed value will fall with some percentage. We want to provide this because, studies have shown by giving numerical uncertainty or the actual probability, it can help make users and stakeholders make better decisions and ultimately have greater trust in the forecast. Now, there are some, notes to be mentioned with a probabilistic forecast. One, every forecast has uncertainty, but now by providing you the direct numerical uncertainty, we can give you the actual error bars instead of having you, our users and stakeholders, try to take it into account yourself to provide you more information. And another key point is, there's no clear right or wrong answer in a probabilistic forecast. Sometimes the unlikely event at 20% happens, and that's just kind of the nature of the beast. Next slide. To take this home, I just want to express why we need this. Here are two studies that show the difficulty people have in interpreting probabilistic terms. So the main item to see here or take away is that without context in the form of numbers, people interpret things very differently. So on the left was a University of Oklahoma study, and you can see down in part B of it, possible is interpreted by the population either as 25% chance or a 50% chance. So that makes a big impact because we have two evenly distributed peaks. And not only is this a problem in our field, but it's probably a problem in your field. And it's been a problem all the way back since the 1970s with the CIA study on the right. Basically, we can see that due to imprecise and unqualified terms, people are interpreting these terms quite differently. And that's something we do in the Weather Service. You know, we might say, slight chance or chance. Well, for different people, that could be 10% or 50%, which would change what type of action you can take. So instead of using terms that are, unqualified in what they actually mean, we're going to try to avoid this and explicitly communicate what the numerical uncertainty is. Next slide. So, Larry and Mark, I think, showed this event. This is that May 30th severe thunderstorm weather event we had. And, this is a probabilistic forecast. When it comes to this map, all outlooks relate to the chance of severe weather occurring within 25 miles of any point on the map. So what that means is, while the storms aren't slightly severe, what it tells you is that what is the probability of a severe weather event, 1-inch hail or larger, thunderstorm winds 58 miles per hour or greater, or a tornado. So on the right side of it, you can see a wind probability legend. So what it's saying here in that yellow area is there's a 15% chance of a thunderstorm wind gust greater than 58 miles per hour within 25 miles of your location. And you can see there's also a hatched area where they're saying there's a significant chance for significant thunderstorm gusts exceeding 74 miles per hour at your location at a 10% chance or higher odds. So that's probabilistic information you can have right in your event. And you can kind of relate that back to odds of it occurring. So if there's less than 1% chance of this happening any given day, which is quite true up here in Northeast Oregon or South Central Washington, a 30% probability means the risk for severe thunderstorms winds is 30 times larger than normal. And it's probably even larger than that, because it's probably much less than 1% chance of this happening at any day. So go to the next page. So this was actually a good forecast. This is kind of the verification. So we can see those symbols, the triangles are hail reports, the squares are wind reports. And you can see that this was a pretty well forecast event, with stretching from all the way down in South Central Oregon all the way up into Northeast Washington. So you can see that there was over 60 storm reports issued, and we even saw that significant thunderstorm damaging wind occur, with winds ranging from 70 to 150 miles per hour occurring in the area of Culver to Metollis, Oregon. So now here's another example of a probabilistic forecast. So all this shows is the high temperatures for next Monday. From yesterday morning is when I got this. So this is a 7.5-day forecast, but basically what it's saying is, on the left-hand side in Pendleton, there's 80% chance that the high temperature will fall between 66 degrees and 91 degrees, but the best forecast is the temperature of 82 degrees. And in the upper right is the chance of a high temperature of 80 degrees or more. And you can see Pendleton has a 65% chance of reaching or exceeding 80 degrees. So those are two examples of a probabilistic forecast, one being a range and the other just being a probability of reaching some threshold. Next. So now we can do this for river levels. This is a point probability forecast for the Umatilla River at Gibbon. So that's pretty well upstream of Pendleton. It's about elevation of 1,850 feet in the blues. And you can see that there's increasing chances for rises after April 19th, of which there's a 5 to 10% chance of exceeding minor flood stage between April 19th and April 26th. And then again, in that next period, reaching minor flood stage, a 5 to 10% chance between April 26th and May 3rd. And I mean, minor flood stage, that's really minimal or no property damage, but it can still pose some threat to the public or an inconvenience. So that's something where your own threshold, that might be enough for you to take action. Next. And this is another good example of a probabilistic forecast that we do, and this was in some of our DSS briefings this winter, is that we can provide this for snowfall. When it comes to trying to provide that range, we often like to present a low end, best case, or most expected, and a high end. So that's what you're seeing on the right-hand side. And the left-hand side is from a different event, but you can see that we're providing the 1-inch snow probability. And that could be a big difference. Say you're a plow driver or DOT, that might be enough probability or likelihood of it happening for you to take action. Next page. I guess the biggest takeaway, is that not all this information is currently suited to be presented as probabilistic forecast information. Fire weather, especially, when you look at some of our parameters, transport winds, mixing heights, we're not quite there yet to have the data to adequately serve it. So that's why, we don't do that right now, or, we don't have the right method to effectively communicate it. Communication will sometimes be a challenge as we move in this direction, but you should know we'll always try to do our best. Ultimately, this is a team effort, so I think feedback, questions, and comments as we move further in this direction will be key, as there's a clear need to evaluate, impacts from probabilistic forecasts and what approach is best. Is one form better for fire weather, say chance of exceeding or chance for wind gusts exceeding some threshold, or is it better to have a range where we can say 50% of the time it's going to fall within here, or 80% of the time? So that's something to kind of take away and think about as you see this service be provided by us, to hit us back with what you thought about it. And that's all I have to say.
Thanks, Ed. Really appreciate that thorough presentation, and especially some of the examples. Probabilistic messaging has been around for a while, but the manner in which we're trying to evolve and use it, and implement it effectively is still relatively new. And so, going forward, I think it'd be good to try and identify, a handful of folks that are willing to experiment with us, to try and refine our messaging and find the most effective ways to reach people.